Gurubhyo Namaha. In the series of videos on the chapter set theory, in present video, I am going to discuss about the concept of power set. Let me explain this concept by using an example. Let I have set A. That set contains two elements, 1 and 2. Now my present job is I need to make the list of all possible subsets for this set. Now, say for example, I have set B, for example, which contains only one element. Is B subset of A? Yes. It is subset of A. Why? Because every element of B belongs to A. Therefore, B is subset of A. Similarly, equal to 2 is also subset. And we know very well, empty set is subset to itself. And finally, the set itself is subset to A. Therefore, here I have 1, 2, 3, 4 subsets for A. Can you find any other subsets? No. Now, what I do, I write these subsets as the elements of another set. Let's say 5, 1, 2, and finally 1 comma. What is this set? This is set of subsets of A. Set of all subsets of A. And this is called power set. Power set. So, what is the definition of power set? Power set. Definition. Let A be any set. The set of all subsets of A is called power set of A. We have symbol for this denoted by P of P of A. Power set. So let A be any set, then the set of all subsets of A is called power set of A, and denoted by P of A. Now write one example for this. Example: A is equal to 1 comma. Write P of A. Now P of A is equal to, already we discussed this example. P of A is equal to, first I write empty set. Next one I write 1. Next one 2. The next one, the set is P of A. Now my next concept is, without making the list of elements of P of A, of elements of P of A. Again repeat, without making the list of subsets of A, that means power of A, can I find the number of elements in P of A? This is my next concept. Please take it. Number of elements of our set C. E. Now I'll write one result here. If the set A contains n number of elements, then P of A contains 2 power n number of elements. We have to prove for this statement in permutations and combinations, or we can do this in the chapter mathematical induction. But I want to verify these results by the examples. One by one, let me explain. For example, verification by example. Okay, first let example 1, let A is equal to empty set, that is fine. So A have 0 number of elements. Then as per these results, the number of elements A contains zero number of elements. Therefore, P of A should contain two power 0, that means 1 element. Okay. Theoretically, yes, I proved this empty set have only one element in its power set. What is that element? And see, every set is subset to itself. That means pi is subset to itself. Therefore, P of A is equal to here. P of A is equal to here. One element. This is true. Now, let me verify the results by using next example. Example 2. Example 2. Let A have only one element, say from X. So here the number of elements in A is equal to 1. The number of elements in A is equal to 1. As per theory, my power set must contain 2 power 1, that means 2 elements. Therefore, number of elements in P of A as per the rule 2 power 1 is equal to 2. So theoretically, yes, we need to have 2 subsets A. Now let me find the subsets of A here. So here I am writing P of A. As usual, empty set is subset to A, therefore one set. And the set itself is subset. Any other subsets for A? No. For P of A have two elements, that is pi and x. Next one, let me verify these results for another example. Let example 2, example 3. Let A is equal to x comma y. So here number of elements is equal to 2. Therefore, number of elements in P of A is equal to 2 square 4. Oh, let me find the list of subsets for A. A is equal to, you have let me write subsets. So I am writing P of A here. As usual, first empty set is its subset. Next one, a set which contains only x can be a subset. A set which contains 2 can be a subset, and the set itself. So, by verification, practically also I proved P of A have 1, 2, 3, 4. So P of A is equal to here number of elements in P of A is equal to 4. The result is verified. So again repeat, if a set contains n number of elements, the power set must contain 2 power n. If a set contains only 0 element, the P power set is 2 power 0, 1 number of elements. If a set contains only 1 element, power set contains 2 power 1 is 2 elements. If a set contains 2 elements, its power set must contain 2 square 4 elements. So practically it is proved. Practically. But mathematics won't accept examples. You have to give a theoretical proof for this one, but you have proof for this one, again repeat, in permutations and combinations. Now, I will tell you now how to make the list of subsets of a given set. How to make list of subsets of a given set. Now, by an example, I will explain you this concept. The next concept is universal set. Universal set. It is very simple. Universal set means in a particular context. Suppose in a particular problem we are dealing with say two sets, set A and set B. For example, set A and set B. Between these two sets, which set is superset? Which set is superset? Then that set is called universal set for that context only. It's not for all. For that context only, So, whichever is the big set in that context, that set is called universal set. I'll take one more example. For example, I have a set of natural numbers 1, 2, 3, 4 and what else? I'll say set of even numbers. Even numbers 2, 4, 6, 8 and so on. I take set of odd numbers. I take 1, 3, 5, 7 and so on. If you observe carefully, my E is subset of n, my O is subset of n. That means in this one, if you are discussing a problem which have only these three sets, then this n is called universal set in that context. So let me write definition of the universal set. In a given context, the superset set of all the given set is called universal set of that context only. And what is symbol here? Denoted by universal set is denoted by most of the textbooks capital U, or you can use the symbol mu, either U or mu. For you, U is the comfortable rotation. Example. Let n is set of natural numbers. Therefore, capital N is equal to, you have 1, 2, 3 and dash dash dash. Even numbers, set of even numbers 2, 4, 6 and so on. Odd numbers 1, 3, 5 and so on. Now here in this context, n is a superset, therefore n is universal set here. Suppose you are discussing, okay, this example is enough. Please take down.